Welcome to ITAG's Testing Forum, where we're going to explore the future of engineering excellence, and welcome you to the Atlantic Festival 2024. This year, we celebrate our 10th annual Atlantic Festival, with events running across 10 days with 60 speakers hosted in various venues across Galway. My name is Darren Muldoon, and I am the Galway site lead for Liberty IT, and I'm also the ITAG Testing Forum lead. And I'm delighted to be here today to host this event, and thanks to Portishead for providing the venue, as usual. On behalf of the Atlantic Festival Committee and ITAG, I'd like to welcome you, our audience, and a special welcome to our guest speakers today. We appreciate their time and their support of this event and also the Testing Forum. If you or any of your colleagues would be interested in joining the forum, we'd love to hear from you. Just talk to one of our committee members afterwards, or else email info@itag.ie. So, to get us started then, our first guest speaker is Stephen Conneely, QE Chapter Lead with Fidelity Investments. Stephen has 15 years of experience in software quality assurance and engineering. Currently, he's a chapter lead, where his role involves managing and mentoring, as well as crafting and driving quality strategies. In addition to this professional experience, Stephen is also pursuing a postgraduate certificate in AI. Stephen is going to cover the impact of AI on quality engineering and the SDLC, so please welcome Stephen on stage.
Good evening, everyone. How are you all? As Darren said, my name is Stephen. I am a quality chapter lead in Fidelity. I do bring 15 years experience in quality, and I am currently doing a postgrad in AI, which is where a lot of my insights for today are coming from. Before I get started, this presentation is meant to be a conversation starter, not a monologue, so feel free to jump in with questions or insights at any time. We do have a panel discussion at the end of the two talks, so if your question will be more suited to that, I'll just ask you to hold on to them. So let me set the scene first by talking about what is quality, what is QE, and the changes that have happened over the last 20 years. So QE has evolved over the last 20 years. Traditionally, QA, quality assurance, was more reactive than proactive. QE focused on detecting and fixing defects after development, creating a reactive end-to-end process. QE shifts the focus leftward. So you might have heard about shifting left and what that means. It simply means that we're shifting the focus on quality from the end of the process to the start. Shifting leftward. So we are prioritizing proactive quality practices earlier in the software development lifecycle. What was a big driver for that shift left? Automation was introduced. So automation of manual testing processes was introduced roughly 20 years ago. I know in my first role, one of the first things I was told to look at, or tasked to look at, was Selenium. I don't know if you know Selenium or heard of it in the past, but it's a UI testing tool which will record manual testing steps and run them automatically for you. With automation and continuous integration, automated tests and continuous delivery, automation ensured that quality checks were happening early and often. As changes were integrated frequently, automated tests ensured consistent functionality and reliability, quickly catching issues and feeding them back into development teams. So what are the key benefits of QE? You have early error detection, and with that error detection you have cost efficiency. So the earlier you catch issues in development, the cheaper it is to fix it. If you are constantly sending back defect-ridden functionality back to dev, back and forward, whatever it might be, that's going to take time. It can delay releases, it can impact cost, it can impact quality, and it can impact reputation. And that's where QE steps in to try and fix those issues. What are the common challenges in QE? So QE is a risk-based approach. It relies on identifying, assessing, and prioritizing risks to focus on areas that are critical to project success. To put it shortly, QE cannot test everything. There is not enough time in the day, not time in the week, or not enough resources to handle it. So we have to identify where we need to focus to ensure that we catch all of the critical functionality and hope that nothing goes by undetected. It is time consuming, as with all processes are. Manual testing and quality assurance are time consuming. Every software change or addition demands a new round of testing, which becomes increasingly lengthy as a project grows. So each time a change is made, your Jenkins pipeline runs, your automated test suite runs, you have to keep on continuously adding to your test suite, maintaining that. This all takes time. Human errors, it's not fair to just put this on QE. Any process that is driven by humans is going to be prone to errors. But the examples of errors that can be laid at QE's feet might be overlooking certain issues, not understanding that something is a defect when it is, misinterpreting requirements, and mistakes in actual execution of test cases. These can lead to undetected bugs, broken functionality, and then if they were to be released into production, it could lead to financial or reputational damage. The fourth, probably most prominent challenge in QE, especially in larger corporations, is complexity in dealing with fast data sets. So modern software systems rely heavily on massive data sets. The time that it takes to manage and maintain test data for various scenarios can become unmanageable as that volume grows. The systems that you use to create the test data to ensure that you're following all risks, guidelines, whatever they may be, they all take time. I would hazard a guess 20-25% depending on what the project is. So, where can AI be applied in QE? I've tried to highlight key processes or several areas of AI or QE where AI can be applied. This list is not exhaustive by any means. I will be using terms like neural networks or reinforcement learning. I don't intend on defining those today or explaining what they are, but if anyone has any questions afterwards, after we talk, I'll be happy to talk about them then. So, the first area, automated testing. This is not the same as test automation. This is actually remarkably different, but I will ask you to try and imagine a world where software testing is as easy as teaching a child to recognize shapes. That is the power of a neural network in automated testing. They can quickly identify and interact with elements in a software application, such as, much like a child would recognizing and interacting with shapes. And just like a child learning from their mistakes, AI can use reinforcement learning to enhance test automation, refine tasks, and allowing for faster execution of test cases. Unsupervised learning, which is another type of AI technique, can even suggest tests for comprehensive coverage by grouping similar functionalities. And this is where we talk about risk and our edge cases and identifying all of the different scenarios that we might not have identified in the past. Predictive analytics. Generative AI models are extremely good at identifying and learning from patterns. They can analyze vast sets of test cases and quickly spot trends, recurring issues, and potential points of failure that a human might miss. By providing insightful patterns and correlations, these models can drastically reduce the time spent on troubleshooting and debugging, thereby increasing productivity and efficiency. Generative AI can also predict potential issues before they arise. This is the holy grail. If we were to get this right, if this was to take place, then it would cut down a lot of the work and ensure quality from the very start, just by analysing the code and finding defects before any testing actually takes place. It can forecast likely points of failure in new or modified code, and this predictive ability means teams could proactively address them, saving significant time and resources that would otherwise be spent on reactive problem solving. Bug detection and triaging. So detecting bugs in software can be like finding a needle in a haystack. But with deep learning models, this task can become much easier. These models can analyze code, test results, and production data to spot inconsistencies and errors. Classification algorithms can then categorize and prioritize bugs based on various parameters, enabling efficient bug management. NLP, or natural language processing, models can analyze textual data like bug reports and automatically triage them and extract meaningful insights. Self-healing automation. Picture a world where software tests can heal themselves. I would say, it's safe to say 25% of the time of quality engineers these days can be spent on maintaining and updating the existing test cases rather than just creating new ones. If we were to have this in place, it would mean that when a software change happens in the code, obviously software, but the test cases would analyze that change, see the link in the test case automation, and make the necessary updates so it will catch it in real time. You would not have to worry about maintenance anymore if this was to take place. Test case creation. This is, I'm not going to say it's an easy one, but it's probably the most obvious one for anyone that's familiar with quality, and it's one that is taking place in most companies right now, at least I would hope so, with tools like OpenAI and Microsoft Copilot. It can be a time-consuming task. You get your requirements, you get your acceptance criteria, you plan out what needs to be tested, the negative, the positive, whatever they might be. With generative AI, you could just simply put your requirements into these tools, ask it what test cases need to be covered with this. I'm a UI tester, I'm using such and such a tool, Playwright, Selenium, whatever it might be. Generate the test cases for me. Think negative, think positive, think edge cases, whatever it might be, and it can generate that for you. User experience testing. Ensuring a good user experience is critical in software development. Generative adversarial networks, I'm glad I wrote this down, or GANs, can simulate user interactions and behaviors like software. Creating realistic UX testing scenarios, AI can apply sentiment analysis to interpret user feedback and reviews, pinpointing areas of the UX that may need improvement. And CNNs, convolutional neural networks, are especially adept at visual validation tasks, ensuring pinpointing areas of the UX, ensuring UI elements appear consistently across different device screens. Now, I was talking to someone who actually is an expert in AI, and when I mentioned this to them as a possible use case, they took a step back and said, actually, yeah, those tools can be used in such a way, but what the problem would be a scaling issue. So currently, tools like GANs and CNNs, while they could serve this purpose at the moment to scale them down for an industry level tool or whatever it might look like, currently doesn't exist. But I'm an optimist, and I've seen things that I've been told need to be scaled down in the past, and they have been scaled down and they work. So I think it's something that we could look forward to in the future. Maybe not as closely as all of the rest of them though. Finally, test data generation. So, generating realistic test data that simulates user behavior or sensitive information is a complex task. Getting it right can be difficult, often hindered by data privacy concerns. AI can generate synthetic data that mimics production data patterns while preserving privacy. This would ensure comprehensive testing without exposing sensitive information. Okay? So, with all of that said, what are the potential impacts on quality and the software development lifecycle? I would imagine if we were to employ these tools as described, we could see faster and more efficient testing. AI accelerates testing by automating repetitive tasks and optimizing test cases. This in turn will reduce time required for testing cycles, leading to quicker delivery and shorter time to market. Improve quality and reliability overall. So if we're eliminating risks or we are increasing our test scope with more test scenarios because we have more time to run them, we're reducing risk and improving quality and reliability overall. Also, continuous learning helps refine the testing process. So through each cycle, any improvements that can be made, AI can suggest them to us, or we can identify them ourselves. Enhance accuracy with machine learning models. So machine learning models can analyze vast data sets and enhance testing accuracy, suggesting the most efficient test cases. They can help categorize bugs more efficiently and provide valuable insights for improvement. All of this leads into significant cost savings. So going back to the very first slide when we talk about the cost to fix errors, depending on where they're found, if we are finding errors from the very start, if we are preventing them from becoming errors in the first place, and we are producing quality code all the way through. You will be saving time, saving money, and improving quality and improving the reputation of the product that's sent out. Finally, reduced human intervention and fewer errors. So the more tests that were previously manual, that are now going to be automated, it means less human interaction in the test execution process, and the test creation process, and by handling repetitive tasks and streamlining testing workflows, AI will allow teams to focus on strategic analysis and problem solving. But it's not all rainbows and lollipops. So what are the potential concerns? Again, these concerns are it's not an exhaustive list, it's just, I think they're the most obvious ones that I could highlight myself and talk to today. An over-reliance on AI. I've just talked for about 10 minutes about how great AI is, but we cannot use it as a crutch. We cannot, like with any tool comes out, we have to ensure expertise in the areas of those using it. So whether it be a developer, whether it be a system analyst, a quality engineer, whoever is using these tools, they are the ones that set the standard. They're the ones who ensure the quality and the outcome. They cannot, at the moment, they can't depend on AI to do that for them. The way I tell people in Fidelity who are working with AI, or I try to get them to use various tools like Microsoft Copilot, is trust but verify. You are the expert, it is not. Data privacy issues. So, especially in Ireland and the EU with our GDPR issues, AI models often require significant data for training and validation, and that can include sensitive information. Mishandling of this data can result in privacy breaches, raising ethical and security concerns. Bias and fairness in algorithms. AI can exhibit biases due to the data used in their training. So how the AI or the algorithm was trained in the first place will determine how useful it is. Depending on the good data that was used, if it was bad data that was used, whatever the case might be, will determine what the biases are. We have to be aware of those biases when using them. I've heard of horror stories of HR departments using AI to determine what CVs are valuable and what CVs are not, and it became clear very soon that they were dismissing women who might become pregnant and other bad things that they shouldn't have been doing. I don't know the exact details off the top of my head, but that's an example that I've heard in the past. Impact on testing efforts. So I've talked about how good it might be, but the introduction of AI-powered testing requires reshaping existing testing efforts to leverage AI effectively. This process must minimize redundancy and find new roles for traditional manual and automated testing teams where possible. Unemployment concerns in the QA sector. So it's not just the QA sector, it's any sector that can leverage AI. Anyone you talk to who is unsure of AI and what it might mean and what it might bring to the table, the common concern is, will it take my job? I cannot answer that question, but I can give my insight into that. Right now, I do not see that being the case. I see AI being the next way we work. I can see in the next 10 years that we will not be talking about AI. AI will just be integrated with all the various tools we use. We can talk about how automation was introduced in quality, how that has sparked similar fears in people. I'm a manual tester, I don't know how to code. What will this mean for me? It means reskilling, upskilling, understanding how to use the tool, being that expert in your area and using the tools effectively. So conclusion, what we talk about today, AI integration into QE. I think AI is poised to revolutionize QE and other activities in the SDLC. It's going to offer faster, more efficient testing, improved software quality, and significant cost savings. Organizations that embrace AI will gain a competitive edge in the digital era. Integrating AI into QE marks a significant shift from traditional processes. By automating time-consuming processes, reducing human errors, and managing fast data complexities, AI can dramatically improve efficiency, accuracy, and speed. I've addressed the concerns that we just talked about there, and I would like to say that as technology evolves, AI's role in QE will expand, and elsewhere as well in development, system analysis, whatever the role might be. The fusion provides a path to adaptive, high-quality products and services that will set new industries' benchmarks for excellence. I don't think it's an understatement to say that we stand on the cusp of a new era with AI. Professionals, businesses, stakeholders, they all need to embrace AI. The potential that AI can bring, invest in understanding how to use it, what its role could be in software development, what that might look like, and shape a future where quality is assured and evolved. Okay, any questions?
Yeah, you talk about the benefits, right, and the concerns, and they both seem to be, when you look at the benefits, really good, and when you look at the concerns, they completely articulate the benefits, right? It has to be a balance, right, the middle ground, so what's your thought on that?
Yeah, and I didn't mean that to be the case. I didn't want for the potential concerns to outweigh the benefits, but I have to admit they were there. I can't talk about how good it's going to be without talking about how we are going to interact with it. And those concerns are there, they are valid. What it means is we have to put structures in place, frameworks in place, on how to leverage these tools and harness them the way they can be. I think the benefits far outweigh the concerns. I just think it's about people having the confidence to take on the challenge of integrating into their systems, especially in these large industries. So you have large corporations who are risk averse, slow to adapt. I think it's about being upfront and honest with those concerns, not hiding them away, which is what I'm trying to do here, and talk about what can it bring to the table. When you talk about numbers, you talk about money, then they might start listening. So that's another way to handle it as well.
Is there any assessment or quantitative assessment on if the AI in quality engineering will replace the process, right? I'm talking about the full process of generating, coding, testing, even putting into applications or use cases. Is this going to be more kind of faster than what is expected? But maybe the computing capacity and all the elements that are behind that will cost more for the industry than really having someone, 50 developers to just test the application. Is there any kind of indications in that direction?
I don't know the answer to that question, but I might ask you to save that for the panel afterwards and someone else might be able to handle it, because it's a really good question. Thank you for that.
No problem. But thanks for your presentation, it's fantastic.
No worries. Any other questions?
So maybe I can, in the context of generative AI, right? Because you mentioned that all these scenarios that we don't even imagine might exist with the AI injected or connected will be more kind of diverse. And it's well known that at the end, the end user, the user experience is the ultimate objective of software. So how this AI matches, this generative AI matches the UI experience, because at the end humans needs to inject that to the AI and then the AI needs to inject to the human, or how this is.
Yeah, so there's two parts to that I think, well, what I would answer is humans can't be outside of this process. They have to be in there understanding what the AI tools are doing, refining what the AI tools are doing so they understand that what we as humans are looking for. So having that eye on quality, what the expectation is for user experience, we are still going to be in there, designers are still going to be in there, and part of that process, not outside of it. The second part I would say is sentiment analysis, which is already in place. So when you refine your sentiment analysis, you take your feedback, you can make changes quite quickly based on that if you have the right framework in place. So it's going to be a combination of humans and AI working together to ensure we have the proper user experience where possible.
It's not the case that maybe we're just moving the humans to the last mile, because now the humans are embedded in the process, right? Every agile process, the human comes.
Absolutely not. We have to do it from the very start. And this is something that's changed. This is not just about AI, this is about quality and what engineers do. And this has been an uphill battle as well, as well. Quality has to be injected from the very start. We have to be there when we are planning, when we are considering what we might do, so we have an understanding of what will take to test the end product, what will it take to ensure quality from the start, what tools we have to do. So it's the same with AI and when we might inject it. And humans being there at the start, quality engineers being there to start that process.
Sure. Thank you.
You mentioned one interesting approach related to QI, basically risk-based, you know. Do you see currently in the market any AI-based tool which would make that better than a human being? Well, because this risk management, it's a little bit tricky story. You know, I used to work in the past, and for that reason, I'm just curious.
I haven't seen any. I will say that I have used generative AI for my risk management assessments. So I have frameworks in place that I would have leveraged in the past that I would have used, so set the framework within generative AI and then feed in details of the project, feed in details of the acceptance criteria, and let that do the work for me, or help me identify things I might not have thought of using the same framework. But is there a product out there? No, but it's an opportunity. So anyone can take that on. But no, that's a really good idea.